Hello everyone, I am Savannah Bates, and this project was on opioid overdose and its relationship spatially with model-predicted opioid misuse. So just how bad is the opioid crisis in Ohio? Ohio actually ranks second worst in the nation for overdose deaths in 2016, and this caused over 4,000 deaths of Ohio residents. To put this number in comparison, that number is higher than the combined car fatalities in Ohio from the years 2013 to 2016. 58.2% of these deaths were caused by fentanyl and related drugs. Fentanyl can be hundreds of times as strong as heroin, and carfentanil, which came on the scene in 2016, is thousands of times stronger than heroin and 10,000 times stronger than morphine. So this crisis really is a big problem. It's being driven by fentanyl and related opioids, and some would even call it an epidemic. So what do we want to do about it? The aim of our research was to identify and map areas with high values of overdoses to misuser, and we examined this ratio with a model that incorporated the RTI-developed synthetic population, reports of opioid misuse from the National Survey on Drug Use and Health, and of course, the Cincinnati EMS data on overdoses. So more about the synthetic population. Here we see a graph of Cincinnati, and we're looking at the race demographic here as an example of what the synthetic population incorporates. And it was developed by RTI in 2014. It uses 2010 US Census Bureau data, public use microdata samples from 2007 to 2011, along with other data sets, and it creates a representation of every individual and household in the US. And this is really important. Rather than using just raw census data, we use this synthetic population to protect the privacy of individuals, because while on the aggregate level, the synthetic population and its demographics match the US Census Bureau data and other data sets used to create the population, on an individual level, no individual, at least with very little probability, would match an actual individual, so privacy is conserved. So once we have our synthetic individuals, we assign them a misuse probability using our misuse model. And this model was achieved by looking at the National Survey of Drug Use and Health data. And basically what is done is each individual, based on their demographic factors like age, sex, high school education, and race, are assigned a probability that they would misuse opioids. And then we do a Monte Carlo simulation to actually assign them a misuse status based on their probability, either misuser or not misuser. Finally, we incorporate the Cincinnati EMS data. We want to make sure we're only including overdose events, and we remove any data that doesn't have spatial information or has spatial information outside of Cincinnati. And we do this because we're really looking at locations within Cincinnati that seem to be really at risk for overdose events. So once we have our synthetic population and individuals and their demographics and their misuse status, and we look at the number of EMS calls, we make a grid of Cincinnati. We divide it into cells and calculate the number of people in the cell, how many of them are misusers, and how many calls took place in that cell between January 2015 and April of this year, 2018. And then we look at this ratio, which we call R1, our ratio of interest, which is a modified representation of the calls per misuser in any given cell in Cincinnati. And so, for instance, if we have 2 calls in a cell and no misusers, then our ratio would just be 3. So once we have this R1 value, we plot it on a map of Cincinnati, and we see that there are cells that have extreme values of R1, those being our darkest blue cells or our deepest red cells. And we want to know what is it about these cells that makes them exceptional. So we're digging through, looking at the contents, and we notice that in our darkest blue cells, a lot of them seem to be residential living areas, and in our darkest red cells we see commercial areas, urban areas. There's some train tracks and rural areas also here. And actually, while we were digging through these dark red cells, we noticed that in our deepest cells or around groupings of these darker red cells, there was a particular fast food restaurant that seemed to pop up. And this restaurant, while we only found the pattern with this restaurant particularly, it has traits that might be represented in other areas like gas stations or similar fast food chains, that intervention strategies could be implemented in these areas and be successful. And so sure enough, we went through and calculated or figured out what was in all of these cells for our highest and lowest valued R1 cells. And in fact, every single one of our highest cells was non-residential, and every single one of our lowest value cells was residential. And this got us thinking, because this supports a hypothesis that people on the forefront in Cincinnati trying to fight this epidemic noticed, and that the behavior accompanying opioid misuse is different from other narcotics. With other drugs, the user will typically obtain their drug from a dealer, or if it's, so for instance, they'll obtain their cocaine from their dealer, they'll return home, use their drug, and if they were to have an overdose event, their home would be where it would take place. However, with opioids, they're so highly addictive and the withdrawal symptoms are so strong, they typically use the drug as soon as they obtain it. And this could be in, typically non-residential areas. So we wanted to know if this pattern held for all of Cincinnati and not just our darkest red and blue cells. So in here, we're looking at, again, our log R1 map on the left of Cincinnati, and we compare it to a zoning map of Cincinnati, where we've simplified sort of a zoning scheme and colored commercial zones red, residential cells blue, and industrial park areas yellow. And we see striking similarities between these two graphs, even though the basis behind generating them, you wouldn't expect a relationship between Cincinnati zoning codes and high values of R1. And so we believe that intervention strategies could be implemented and specialized to the areas where we see these patterns holding strongest, be it the darker blue cells or the red cells. So just to conclude, we see that we've used RTI's synthetic population, which gives us representation of every individual and household for Cincinnati, and we use the National Survey of Drug Use and Health to assign our individuals a probability of misuse. And then using EMS data, we find out the basic ratio of how many calls per misuser occurred in any location in Cincinnati. And we found these places in Cincinnati that have exceptional values. And we compared this with zoning maps to see that the highest ratio of overdoses seem to happen in commercial areas, whereas the lowest ratios seem to happen in residential areas. And we hope that this work allows for targeted intervention strategies. For example, in a deeply red cell, we noticed that there were a lot of fast food chain restaurants, particularly gas stations. These areas are often open late hours. The restrooms are typically small or single-stalled, and they have cheap nourishment. And we found one restaurant in particular that popped up near and around several of these dark red cells. And so a potential intervention could be training these employees to know how to respond in an overdose event. Of course, this is a double-edged sword, because then maybe misusers will see these areas as sort of safe havens for them to use drugs, and knowing that someone there might know what to do in case they take it too far and have an overdose event. In fact, at a fast food restaurant, there was a young couple just in 2017 that overdosed with their young children there, and in that fast food restaurant bathroom. So a simple policy could be requiring these fast food chains or gas stations to keep their bathrooms locked, and require that a customer requests a key. before accessing the restroom. And so while more work needs to be done to understand what intervention strategies will be most successful, we hope that this work at least provides a decent groundwork for where these interventions might be most successful. Thank you so much for your time and attention. Here's my email if you have any questions, and then a couple of references about the synthetic population developed by RTI. Thank you.